Nature égale futur, au cœur de la vague. Qu'est-ce qu'une vague? Comment se forme-t-elle? Pourquoi certaines vagues sont-elles plus puissantes que d'autres? La science peut-elle mieux analyser ce phénomène naturel afin de pouvoir protéger nos rivages et nous prévenir des inondations côtières liées au réchauffement climatique?
All the waves we see today in the ocean are formed by wind. There are usually three factors that determine the size and also the energy of the individual waves, which is at one point certainly the strength of the wind, then the duration, basically for how long does the wind blow, and the third component is the fetch. The fetch is the area that the wind affects. There are typical locations where we always see relatively large waves, and at other locations smaller waves. And this is all driven by the bathymetry or the ocean floor. One famous location here at the Côte Basque is Belhara. Belhara is an underwater rock formation that focuses wave energy exactly to that spot. And it only works when the waves are really big and also very long, so very energetic. But it's one formation where we always see relatively large waves. So when a wave arrives at the coast, it's usually subject to several processes. Two most significant processes are refraction, and the other one is shoaling. Refraction means the bending or the change of the wave angle with respect to the bathymetry. The bathymetry is seafloor of the ocean. When the seafloor is shallower, the wave is slowed down and automatically the wave turns in the direction of the beach. Shoaling, on the other side, describes the growth of the wave at the shore. So we can think of the wave being compressed, and since the energy has to maintain constant, the wave height increases, and that's the shoaling process at the beach before the wave breaks.
Une meilleure connaissance des vagues grâce à leur observation permet de les modéliser et de les simuler à l'aide de calculs mathématiques novateurs. La chaire HPC Waves en Anglet a ainsi développé des modèles très précis et très performants qui ouvrent la voie à des solutions mieux adaptées aux effets des vagues.
So HPC Waves stands for High Performance Computing of Waves. So we try to not only improve the accuracy but also the speed of the computations. So today we actually have a variety of very powerful and also very accurate numerical models that can not only predict but also simulate different scenarios of water waves to anticipate negative effects, because these models run fast. We can simulate a lot of different scenarios, and for example we can compute scenarios that might occur in the future but are not visible today. So that's the big advantage of using numerical models over field experiments or lab experiments. So the Basque Coast is exposed to very energetic waves from the Atlantic Ocean. There can be local storms where the wavelength or the period is a bit shorter, but at the same time the wave regime is very energetic and rough. We have currently some pressure sensors deployed at the beach, for example in Socor, in the Digue du Arta, which is a breakwater that protects the bayment of Saint-Jean-de-Luz. Those pressure sensors are there to understand the forces that act on coastal structures like the breakwater, and to understand what makes, for example, massive concrete blocks of several tons weight move under storm wave conditions. Coastal erosion is a typical problem. Other locations like Grand Plage of Biarritz are very susceptible to energetic waves because there's simply no way to move the society back. I mean, people have constructed right at the front, but there's only very small beach that has to buffer the entire wave energy. Erosion is a very common problem at many beaches. Traditional techniques have always involved a lot of concrete and hard structures to protect the beach from the waves. So nowadays we actually combine hard and soft measurements to allow the coast some kind of a breathing, some kind of a dynamic system to still work, which is, for example, the case of dunes. Coastal dune system, for example, is a very effective and also very cheap measure to prevent from coastal erosion and also coastal flooding, because the dune adapts itself to the dynamic and natural environment.
Récupérer l'énergie des vagues est une autre solution étudiée par les scientifiques et les ingénieurs. C'est ce que l'on appelle les énergies marines renouvelables. La France, avec 11 millions de kilomètres carrés de façades tournées vers l'océan, représente l'un des plus forts potentiels maritimes au monde.